In this video, we'll be talking about 1.3 Objective 6, where we solve applications involving approximate numbers, significant digits, and rounding. Surveyor measured the road frontage of a parcel of land and obtained a distance of 956.7 feet. Based on this result, the distance must be between what two values? Assuming we're using regular rounding rules, it must be between 956.65 if we rounded up to 7 and 956.75 not included if we rounded down to 7. So it must be somewhere between those two values. In 3 successive days, a home solar system produced 51.5 megajoules, 21.175 megajoules, and 10.73 megajoules of energy. What was the total energy produced in these 3 days? So to get the result, the energy from each of the 3 days should be added together, which we'll do with the calculator here in just a second. And then the result should be expressed with the proper precision because we're adding decimal values together. And the answer will be in megajoules. So 51.5 plus 21.175 plus 10.73. And the least precise is the one that's only measured to the tenths position. So we're going to round to the tenths position. We're going to get 83.4 megajoules. This was added. This was precision. Okay. Now we're going to use a calculator to find the voltage in a certain electronic circuit by multiplying the sum of the resistances by the current. So the sum of the resistances here, 15.6 plus 5.81 plus 101.29. And we're going to get 122.7. And that's where we wanted to get it to anyways because of the least precise being to the tenths position, but it worked out exactly in our favor to go to the tenths position anyways. We're going to multiply that by 3.64 amps. And so we have 4 significant figures and we have 3 significant figures. So we're going to multiply 3.64. We're going to round to 3 significant figures. Is going to be 447. Percent of alcohol in a certain car engine coolant is found by performing the calculation shown below. Find the percent of alcohol. The number 100 is exact, so we don't use that for rounding purposes. 40.66 plus 51.69 is 92.35, and then times 100 is 235 in our numerator, and that's to there, and then 106.95 plus 51.69 is 158.64, that's to there, and then 9235 divided by 158.64. We're going to have 4 significant digits. Here is going to be 58.21%. Right? Next question here. A person downloads 3 series episodes from a streaming service onto their tablet. The tablet display shows that the first episode is 51 minutes long and uses 199.9 megabytes of memory, while the second episode is 45 minutes long and 185.4 megabytes. For each of the following numbers, indicate if they are exact or approximate. The number 3 is exact because it comes from a counting process. The number 51 is approximate because it comes from a measurement. The number 199.9 is approximate because it comes from a measurement. The number 45 is approximate because it comes from a measurement. And the number 185.4 is approximate because it comes from a measurement. So all of them were approximate other than the 3, which was exact because we counted 1, 2, 3. Certain smart plug is a rectangular prism with approximate dimensions in centimeters of 5.2, 3.73, and 3.73. Give the volume. So we're going to multiply here 5.2 times 3.73 times 3.73. And we're going to give the correct number of significant digits, which is going to be 2. So this is about 72 cubic centimeters. The energy in kilowatt hours produced by a solar panel is given by E equals A times R times H times P, where A is the area in square meters, R is the efficiency, H is the average radiation on the tiled panel in kilowatt hours per meter squared, and P is the performance ratio. Find the energy produced if A is 25.9, R is 0.11, H is 1280, and P is 0.76. So we have a couple of things that we're multiplying by that are only 2 significant figures. So we'll give our answer in 2 significant figures, 25.9 times 0.11 times 1280 times 0.76 to 2 significant figures. This is going to be 2800. And that's it for the set of problems. We'll come back next time and talk about 1.3 objective 7. We'll see you for the next video.